Alright, let's keep going on our journey with functions. Being able to read information off the graph is a very useful skill. We've already discovered that determining the domain and range of a function from a graph is sometimes easier than determining the domain and range from one of the other three representations. But there are many, many other things that we can be able to tell from a function from a graph. And what we're going to need to do is start with some definitions. The first is going to be symmetry to the y-axis. So, a function is symmetric to the y-axis if it has the following property. If the point xy is on the graph of f, then so too is the point negative xy. And let's illustrate that with maybe a particular example. So what does that mean? If the point xy is on the graph, then so too is negative xy. Well, if this point right here is the point xy, well then this point right here is that same value but in the negative direction. So negative x and the same height y. Okay? And notice any point I pick, this is my xy, then this is the point negative xy. Alright, so let's look at a particular example here. This is the point 2, 2, and notice that this point right here, negative 2, 2, is also on my graph. This point right here looks to be 1.5 negative 2, and this point right here is negative 1.5 negative 2. Now notice graphically what's happening. If I were to take this graph and fold it in half along the y-axis, the graph would lay on top of each other. It would be a mirror image of each other. And that's what it means to be symmetric to the y-axis. Let's see if we can create that from a particular graph. So if this were our graph and I asked you to create we wanted this right here to be half of a function that was symmetric to the y-axis. And we wanted to construct the other half. Well, we would need to make a mirror image of this half onto the other side. So this one right here lies on the y-axis, so it won't have a reflected point. This point right here will be at 1, 2, negative 3, 5. And it would look the same for those points in between. And then this point right here, negative 6, 1, 2, 3, 4, 5, 6, and up to 1, 2, 3, 4, 5, 6, 7, 8. And we connect it this way. Negative 6, 8. So we have constructed the other half of this graph knowing that it was symmetric to the y-axis. And if we were to take this and fold it up along the y-axis, they would be mirror images of each other. Now, functions that have this property are called even functions. Let's see what that definition is. A function is an even function if it is symmetric to the y-axis. That is, f of x equals f of negative x for all x in the domain of f. So that looks a little different than what I've set up here, but it's really the same thing. It's saying that x gets mapped to this y, and so too does negative x. So this corresponds to the point xy, and this corresponds to the point negative xy. Okay? Now we also have symmetry to the origin. Let's define that. Right? A function is symmetric to the origin if it has the following property. If xy is on the graph of f, then so too is negative x, negative y. So what does that mean graphically? Well, let's look at a particular example. So, if this right here were the point xy, well, what would negative x, negative y be? It would mean I would go the same direction over on the x-axis, but then instead of up y, we'd go down y. So that's the point negative x, negative y. Say this is another point on the graph. say that's the point 1, negative 1. Well, then that tells me that negative 1, positive 1 is on my graph. So, given an xy on my graph, the opposite signs of xy are also on my graph. Okay, let's see if we can construct an odd function. Sorry, I'm giving away the secret. Construct a function. If I told you this was symmetric to the origin, can you construct its other half? Well, we have to reflect all points about the origin. So 3, 3 is on the graph, so 1, 2, negative 3, 1, 2, 3 is also on the graph. Let's see, the point 5, 0 is on the graph, so 1, 2, 3, 4, 5, negative 5, 0 is on the graph. The point 7, negative 3 is on the graph, so negative 7, positive 3 is on the graph. So, see my kind of scary drawing skills, but like that, I think. Close enough.